Hello dear students. So, in this session let us discuss about what is meant by conductometric titrations. So, in our previous class we discussed about applications of conductance measurement. Okay. So, conductance measurement is done in very special cases like where we cannot employ the convention method of titration. So, there we are going to use an instrument what is called as conductometer, and we are going to find out the parameters like solubility of a sparingly soluble salt and ionization or ionic product of water, and also the dissociation of a weak electrolyte. So, all these are some of the unique examples which we discussed in our previous class under applications of conductance measurement. So, in this class we are going to discuss about conductometric titration. So, conductometric titration is a method of titration which is performed with the help of an instrument what is called as conductometer. Okay. So, as the name itself says, conductometer means, so it measures conductance. Okay. So, just like how a thermometer or a voltmeter or a colorimeter acts like, in the same way, for example, colorimeter means it measures color, voltmeter means it measures voltage, so like this we can give many examples. So, in the same way, conductometer is an instrument which is used to measure the conductance. Okay. So, conductance means, so how easily a current or electricity is carried by each kind of ions, that is cations or anions, that can be measured with the help of an instrument what is called as conductometer, and that particular experiment is called as conductometric titration. Okay. So, conductometric titration. So, now let us see what is the principle of conductometric titration. So, during conductometric titration what happens is, so just like a conventional titration method, here a titrant will be there and a titrate will be there. Okay. So, we are going to take a titrate or a titrant solution in a beaker, and we are going to measure the conductance of that particular solution with the help of conductivity cell. Okay. So, we are going to use a conductivity cell which measures the conductance of that solution. Okay. So, the whole setup is made in Colruyt bridge, we call it as Colruyt bridge, but you need not to worry, the latest instruments what we are using for the measurement of conductance is of digital conductometer. So, just you have to plug in the conductivity cell and switch it on. Before that you have to do calibration of the instrument should be done, and once after it is done, so the conductivity cell should be thoroughly rinsed with the distilled water and rinsed with the solution of which we have to find out the conductance, and then we are going to measure the conductance at each successive amounts of the titrant is added to it. Okay. So, the titrant is taken in the burette. Say for example, if you are performing any two acid and base experiment, then acid will be taken in the beaker and base will be taken in the burette, and we have to add it in a successive addition like 0.5 ml, 1 ml, 1.5 ml, 2 ml, like that. So, if we go on adding it, so the conductance is going to get changed. Okay. So, how the conductance is going to get changed? The conductance depends upon the two factors, that is, one is the number of ions and the mobility of the ions, how speed or how fast the ions are moving. Okay. So, depending on this, as we go on adding the titrant to the solution or solution which is under examination, so the conductance is going to get changed, and this depends on the nature of the electrolyte, and it also depends on the nature of the electrolyte. So, what happens here during the titration? So, the one electrolyte is going to get replaced with another electrolyte. Say for example, if you are doing a titration of hydrochloric acid and sodium hydroxide. So, here what happens is in hydrochloric acid, so the H plus is going to get replaced with the Na plus. Okay. So, thereby converting the hydrochloric acid into a sodium chloride salt. Okay. what happens to that H plus? That H plus will react with the OH minus which is present in sodium hydroxide and thereby forming a water molecule. Okay. So, this is how the replacement of electrolytes takes place. So, how far the replacement of these electrolytes are going to take place till the equivalence point is reached or end point is reached. Once after the end point is reached, what happens is, so the titrant accumulates, that means there is no electrolytes left to get replaced with each other. So, at this stage we call it as equivalence point, and from the next if we go on adding the titrant to that beaker, so the titrant itself will get accumulated. Okay. So, there again we will find the change in the conductance. So, hence the rate of change of conductance before and after the end point will be different. Okay. So, if conductance is plotted against volume of titrant, so two straight lines with the different slopes are obtained. Okay. So, two straight lines with different slopes are obtained and the point of intersection is called as the end point. So, here we have to concentrate on keeping the temperature as constant and also to keep the dilution effect, to minimize the dilution effect, the addition of the titrant should be in small changes. Okay. So, 0.5 ml is ideal or 1 ml. So, 1 ml successive additions will give accurate values, and also we should keep it in our mind that the concentration of the titrant should be 10 times more than the solution what is under examination. Okay. So, 10 times more concentration if we prepare, so we can get accurate values. So, if a mixture of two acids is titrated, so then we will get two intersection points. Okay. So, which electrolyte is a strong electrolyte? So, that will react first, that means a strong electrolyte will get replaced first and later the weak electrolyte will get replaced. So, that is why we are going to get 2 point of intersections. So, out of which the first one corresponds to the neutralization of the strong acid, and even precipitation titration also can be carried out. Okay. So, this is what the principle of conductometric titrations explains about. And next let us move on to the advantages of conductometric titrations over indicator titrations. So, the conductometric titrations can be employed for titrating colored solutions since no indicator is necessary. Okay. So, compared to the conventional method, why we have to use this conductometric titration? What and all the advantages does the conductometric titration has got? So, that we have to understand first. Okay. So, suppose say for example, you are titrating a colored solution and you have not left with any chance of using indicator, then how you are going to find out the end point or equivalence point? It is very difficult, right? So, at that time, so you have to use a instrument which measures the conductance with respect to the equivalence point or end point. So, that is why instrument is used to find out the end point with the help of the conductance. So, that is why conductometer is used to find the end point. So, that too especially for the colored solutions, since no indicator will work on that, since the solution itself is having color. So, we cannot use any indicator. In such cases, conductometric titrations have got very advantageous over the conventional or indicator titrations. And the second advantage is even weak acids also can be titrated against weak bases. Okay. So, the reaction between the weak acid and weak bases are very poor. So, we cannot perform that with the indicator titrations or by conventional method. And detecting end point is very difficult, but by using this conductometric titrations, even we can find out the end point or equivalence point of weak acids against weak bases. Okay. And next is, if we have a mixture of acids, then also it is very difficult for us to find out the equivalence point by conventional method titration. Okay. A mixture of acids can also be titrated by employing the conductometric titrations. And the next thing is, so the actual principle of a titration is, say for example, if you are performing a titration of acid base, what happens is acids, the electrolytes will get replaced with the electrolytes of base, thereby converting them into a salt. Say for example, HCl and NaOH means NaCl is formed with the elimination of water molecule. NaCl is a salt. Okay, so this is the reaction what is going to actually happen in a titration. But even the salts like sodium acetate can also be titrated against strong acids like HCl. So, this can be carried out in conductometric titrations method. Okay. And the next very important advantage of conductometric titration is precipitation titration. Just like how we saw the example of determining the solubility of a sparingly soluble salt. So, there AgCl was taken as a sparingly soluble salt, and we found out how this conductance measurement will help us to find the equivalence point. In the same way, so the precipitation titration, which could not be performed very easily with the conventional method of titrations, can be easily find out or carried out with the conductometric titrations. And okay, so these are the main advantages of conductometric titrations over indicator titrations. So next part of our syllabus is we have to see the different cases of conductometric titrations. Okay, so there are nearly 7 cases. I think in this session we will discuss 1 or 2. Okay. So, the first case is a conductometric titration of a strong acid against a strong base. Okay. So, the example of a strong acid is a hydrochloric acid and a strong base is a sodium hydroxide. Okay. So, as I explained in the principle, the same principle works in this titration. That is, so let me take hydrochloric acid as a strong acid, which is going to get titrated against sodium hydroxide, which is a strong base. Okay. So, since hydrochloric acid is a strong acid, so it is also a strong electrolyte. That means it easily gets dissociated in water. Okay, so the H plus and Cl minus are crystal clearly formed, and they are independent. They don't have any force of attraction between each other. They can easily carry the electricity which is passed through the electrodes in the reaction. So, that is why we call it as a strong electrolyte. Okay. So, since hydrochloric acid is a strong electrolyte, definitely we are going to find the very high conductance, that is initial conductance will be found to be very high. Okay. So, that is why in this graph if you observe, so let me call this as 0, and in x axis, so the volume of alkali added, that is volume of NaOH added. Say for example, this is 1, 2, 3, 4, 5, 6, 7, 8 like this, and here the conductance measured is 5, 10, 15, 20, 25, 30, 35 like this. So, the initial conductance of hydrochloric acid only will be very high. Okay. So, that is why we are going to get a conductance between 30 to 35 or somewhere here. Okay. So, let me call this point as A. And next what we are going to do is, so we are going to add 1 ml of successive addition of sodium hydroxide. 1 ml of sodium hydroxide is going to be added. So, what happens here? So, the H plus of hydrochloric acid is replaced by the Na plus ions, which moves slower than the hydrogen. Okay. So, this is very interesting. So, when hydrogen is replaced by sodium, so the movement of that electrolyte will become slower. Okay. So, you can assign a reason of atomic mass also here. Since hydrogen is having a lesser atomic mass compared to the sodium, so definitely hydrogen will move in a faster way, whereas when hydrogen is replaced by sodium, definitely the mobility of the ions is going to get decreased. When the mobility is decreased, in turn, so the conductance is also going to get decreased. Okay. So, what happens? All the H plus ions which are present in the hydrochloric acid are going to get replaced by sodium ions. So, next, so till what time the reactions will proceed? Till all the H plus ions are converted into sodium ions. Okay. So, once all the H plus ions are converted into sodium ions, here no HCl is left. So, complete all the HCl is converted into sodium chloride and water molecules. Okay. And next, if we keep on adding the titrant, that is sodium hydroxide. Sodium hydroxide being a strong electrolyte, it is also a strong electrolyte. It is a strong base, and meanwhile it is a strong electrolyte. It will completely get dissociated into Na plus and OH minus, and it has the capacity to carry the current in a faster way compared to the NaCl or anything else. Okay. So, therefore, so when all the HCl is converted into NaCl and water molecule, if we continue adding NaOH to that beaker, what happens is the NaOH will get accumulated. So, that NaOH being a strong electrolyte, again the conductance is going to increase. And okay. So, since here the conductance is going to decrease, so we are going to observe a slope in a decreased manner, and this is the point of intersection. So, where all the HCl has been converted into NaCl, and from here if we say for example this is some 5.5 ml or 6 ml, if we add again 1 ml, that is 7 ml, if I add 1 ml extra if I add, so then that is only of NaOH and nothing else. So, since NaOH is a strong electrolyte, I will find the increase in the conductance again. So, I have to take some 3-4 points of straight line. So, I have to add 1, 2, 3 or say 3 ml of NaOH in 1 ml successive stages, so that I will get a straight line. Okay. So, I am going to get 2 straight lines, and this point of intersection which I have called as X is called the equivalence point or the end point of the reaction. Okay. So, this is the principle of conductometric titration of a hydrochloric acid against NaOH, which is an example of strong acid against strong base. So, what is the procedure, how I am going to do this experiment? Just like how I already explained. So, 50 ml of hydrochloric acid is pipetted into a beaker. Take a 100 ml beaker which is cleanly washed, and to that pipette out 50 ml of hydrochloric acid, and a clean conductivity cell is dipped into it, and the conductance is measured using Colroche bridge. Okay. So, you need not to worry about the setup of Colroche bridge and all. Digital conductometer we have, just plug in the conductivity cell to it and then check the conductance, that is all. Next, what I am doing is, so the given 1 normal NaOH solution is taken in the burette, and 1 ml of it is added to the beaker and stirred well. So, the conductance is measured, and addition of successive amounts of NaOH and the measurement of conductance is repeated until at least 3 or 4 readings are obtained after the end point. Okay. So, that is what I explained after the end point. So, this is the end point. Even after getting the end point, so I have to add another 2 or 3 readings I should take, 2 or 3 ml of NaOH should be added to get at least 3 to 4 readings to get a end point. And okay. So, a graph is drawn with conductance on the y axis. Okay. So, this is the conductance on the y axis and volume of NaOH on the x axis. So, from the graph, so the volume of NaOH corresponds to the point of intersection is noted down, and the end point of the titration is founded out. Okay. So, this is how we are going to do the experiment. And the second case is, so conductometric titration of weak acid against strong base. Okay. So, now let me take acetic acid example as a weak acid and a strong base is NaOH, the same what we have used in our previous case, same thing, but here instead of strong acid I am taking weak acid, that is acetic acid. Okay. So, here also the principle is same. So, since acetic acid is a weak acid, so the what is that? It will have initial conductance of low. Okay. So, that means CH3COO minus. So, the will be one electrolyte and another one is H plus will be the another electrolyte. So, it will have very poor or very low conductance. Okay. So, during the titration what happens is the electrolyte acetic acid reacts with NaOH and is replaced by the salt what is called as sodium acetate, that is CH3COONA. This is sodium acetate. Okay. So, when acetic acid reacts with the strong base, just like how we saw in our previous case, that is sodium chloride was forming, that is NaCl. So, here acetic acid we are using, so that is why sodium acetate will be formed. Okay. So, this sodium acetate, so the salt is replaced with a strong electrolyte. Okay. So, what happens is once after all the acetic acid is reacted, so here the point of intersection will be formed, and once the equivalence point is reached, next if we go on adding the titrant, so NaOH is going to get accumulated. Since NaOH is a strong electrolyte or a strong base, the conductance sharply increases, or suddenly the conductance is going to get increased. Okay. So, compared to the acetate ions, the OH ions of NaOH will move faster. Okay. So, they will move faster, hence the conductance increases at a faster rate after the equivalence point. So, till here, so we will have a flat type of increase in the conductance. There is no appreciable change in the conductance or notable change in the conductance. We have a flat line. Okay. So, since acetic acid is a weak electrolyte, we cannot find out that much of increase in the conductance, whereas once all the acetic acid is converted into sodium acetate, and then if you go on add the titrant, so then NaOH being a strong electrolyte, it will increase the conductance. Okay. So, the graph obtained will look like this. The procedure is same, just like how I have explained. So, you have to take 50 ml of acetic acid in a beaker, and you have to clean your conductivity cell, dip the conductivity cell into that acetic acid and fill NaOH solution in the burette, and plug in the conductivity cell to the conductometer instrument, and then check the initial conductance, that is what is the conductance of acetic acid for 0, that is before adding NaOH, what will be the conductance, and go keep on adding 111 ml of conductance, and note down the readings till a sharp increase is observed. Okay. So, this is the equivalence point, and once after the equivalence point is attained, so we are going to get a drastic increase in the conductance, and we will get a point of intersection. With the help of that, we are going to find out the end point of the titration. Okay. So, these are the two cases. I am going to stop it here, and in my next class we will see the conductometric titration of strong acid against weak base. Okay. So, all the cases are similar, the procedure is same, the principle is same, just we have to look on to the graph, that is all. Okay. So, how the graph will alter based on the different cases which we are going to discuss in the conductometric titrations. Okay. So, I thank you, and we will meet in our next class.